Have you ever just looked at something, your desk, a glass of water, anything, and wondered, what is this really made of? I mean, deep down. Well, today, we're going to shrink ourselves down and find out exactly what everything is built from. Let's get into it.
We're going to start with something you definitely have at home, a salt shaker. Seems pretty basic, right? Just a bunch of tiny white crystals. But believe it or not, there is a whole hidden universe inside every single one of those grains.
So just imagine for a second, what if we could zoom in on one of those little salt crystals, like 1 billion times closer? What would we actually see? What are the true building blocks of, well, everything?
To answer that, we've got to talk about the world's tiniest bricks. And I'm serious, think about it like Legos. You can use those little plastic bricks to build a car, a spaceship, a whole city. The universe works in a very similar way, just with its own special set of bricks.
Okay, so that single, most basic Lego brick in our universal Lego set. That's called an atom. It's the smallest possible piece of a substance you can have. You just can't break it down any further. It's the fundamental unit.
Now, imagine you have a giant bin full of only red Lego bricks, thousands of them, all exactly the same. What you have there is an element. An element is a pure substance that's made of only one kind of atom. Think of a pure gold bar. It's made of nothing but gold atoms.
And here's where the real fun begins. When you start snapping different kinds of Lego bricks together, a red one, a blue one, a yellow one, you create something brand new, right? Your finished model. In chemistry, that's what we call a compound. It's a completely new substance that's formed when different elements stick together.
Take a look at this. This little guy is a molecule of water. It's one of the most famous compounds out there. See how it has 2 hydrogen atoms bonded to one single oxygen atom? That specific little structure is what makes water, well, water.
Now this is where it gets absolutely wild. By themselves, hydrogen and oxygen are both invisible gases. You can't see them, you can't drink them. But when they bond together, boom, they create liquid water, something totally different. Or get this, that salt we started with is made from sodium, a metal that literally explodes in water, and chlorine, which is a poisonous gas. You put those two dangerous things together, and you get something you sprinkle on your French fries. It's an amazing transformation.
So, we've got all these different types of elements, all these different Lego bricks. How on earth do we keep them all straight? Well, scientists came up with an incredible cheat sheet for the whole universe. And don't let it intimidate you, it's really just a map.
And here it is, the periodic table of the elements. It's a chart that organizes every single type of atom, every element that we know exists. Honestly, it's one of the most powerful tools in all of science. So how do we actually read this thing? It's way easier than you think. We're going to use this map to find 4 key pieces of information about any element we pick. You ready? We're going to find its symbol, figure out if it's a metal, check to see if it's a solid, liquid, or gas, and finally, discover what family it belongs to. Let's start with number 1. First up, the symbol. Every single element has a 1 or 2 letter nickname. For example, that big C stands for carbon. H is for hydrogen, and Na is for sodium. Super simple, and the first letter is always a capital. Next question, is it a metal? Easy. See that dark zigzaggy line that kind of looks like a staircase on the right side of the table? Well, almost everything to the left of that line is a metal, and everything to the right is a non-metal. It's a nice clean dividing line. Okay, what about its state of matter? The table tells you that too. If you look at a key for the table, you'll see that the style of the symbol, like its color, tells you if it's a solid, a liquid, or a gas at normal room temperature. As you can see, most of them are solids.
And finally, it's family. The columns that go up and down are called groups or families. And just like in a real family, elements in the same column share similar traits and personalities. For example, everything in this very first column here is part of the alkali metals family. And all of them are super reactive.
All right, let's move on. Now that we know what the symbols mean, we can learn how to read the recipes that tell us how compounds are actually built. And these recipes have a special name, chemical formulas. I know you've seen this one before, H2O. It's the chemical formula for water. But what does that actually mean? What is it telling us? Let's break it all down. Here's how you do it. First, you spot the element symbols. Those are the letters. In H2O, that's H for hydrogen and O for oxygen. Got it? Next, you look for any small number written slightly below the line. That's called a subscript. And here's the key. The subscript tells you how many atoms you have of the element that comes right before it. And if there's no number, it just means there's one.
Okay, quiz time. Let's put this to the test. Here's the formula for baking soda. Can you use what we just learned to figure out how many atoms of each element are in there? I'll give you a second to look it over.
So how'd you do? Let's check our work. Na, that's sodium, no number after it, so that's 1 atom. H, hydrogen, no number, so that's 1 atom. C, carbon, again, no number, so 1 atom. And then O, oxygen. It has that little 3 after it, which means 3 atoms of oxygen. Awesome job. See, you're reading chemical formulas. Okay, for our very last piece of the puzzle, let's clear up something that can be a little tricky. We know that compounds are elements that are bonded together. So how is that different from a mixture? They can seem pretty similar, but there's one giant difference.
Look here. Table salt is a pure compound. Every single tiny bit of it is 1 sodium atom chemically locked onto 1 chlorine atom. But ocean water? That's a mixture. It's got water molecules and salt molecules and tons of other stuff all just jumbled up and swimming around together. They're not chemically bonded, they're just sharing the same space, kind of like people in a crowd.
So think about it. Everything you can possibly see or touch is made from just over 100 of these basic elements. It really is like a giant universal Lego set, which just leaves you wondering, right? What amazing new combinations are still out there, just waiting to be discovered? The possibilities are literally endless. Thanks so much for joining me.